Hello and welcome to yet another one of our revision lessons. I am your host, Mr. Ntsunyani. We will be once again doing a revision on titration reactions. Remember to often pause the video and do your own calculations. It is the best way of learning. Let us look at the question right away. The question says, a student is given a sample of an organic acid V and is asked to determine the relative molecular mass of the acid. A sample of the acid is placed in a previously weighed container and then reweighed. The mass of the container plus the acid is 8.38 grams. The mass of the container alone is 6.92 grams. So this means that the mass of the acid is 1.46 grams, obtained by subtracting the mass of the container from the mass of the container plus the acid. The question continues to say, a student transfers the sample to a beaker and adds 50 cubic centimeters of sodium hydroxide, which is in excess. This means that some of the sodium hydroxide will react with this acid to produce a salt and water, and then some of the sodium hydroxide will remain as unreacted. The excess sodium hydroxide will remain as unreacted. The question continues to say, the contents are allowed to react and then transferred into a volumetric flask. The solution is made up to 250 cubic centimeters with distilled water, and this is solution W. This is solution W. This is W. 25 cubic centimeters of this solution W is transferred into a conical flask and is titrated with 0.100 moles per decimeter cubes of hydrochloric acid. The student repeats the titration 3 times. So we are to use the results of this titration to find the relative molecular mass of this acid W. Let us look at these diagrams to help us understand what is happening here. Here we have our 1.46 grams. This is 1.46 grams of acid V, and it is mixed with 50 cubic centimeters of sodium hydroxide, 50 cubic centimeters according to the question. According to this part of the question, it is mixed with 50 cubic centimeters, so the two will react together. Some sodium hydroxide will neutralize the acid, some sodium hydroxide will remain as unreacted. The remaining sodium hydroxide, which is unreacted, is placed or transferred into this 250 cubic centimeter volumetric flask and diluted up to the mark with distilled water to make W. At this point, I want you to note that the number of moles of sodium hydroxide from here, the mole sodium hydroxide that is remaining was transferred into here and then water was added. So this means this solution and this solution will have same number of moles of sodium hydroxide. They have different concentrations because they are of different volumes, but the same number of moles of sodium hydroxide. This is very, very important in your calculations. We are further told that 25 cubic centimeters is transferred into a conical flask and then titrated. This solution is obtained from here and it is never diluted. It was never received any solute. Therefore, this solution and this solution have got the same concentration. They have got the same concentration. Let us now look at the titration results and record them. These are the results of the 3 titrations: the first titration, the second titration, and the third titration. This will be the initial reading. This will be the final reading of the first titration, the initial reading of the second titration, the final reading of the second titration, the initial reading of the third titration, and the final reading of the third titration. So here we note that the reading is 0 cubic centimeters. I want you to note that when you open the tap of the burette, the solution runs downwards. Therefore, when we read the scale, we read it downwards so that we follow the movement of the solution. So the reading here will be 25.1, 2, 3, 4, 5, 6, 7, 8, and 9. This will be 25.9. And then here the initial reading is 23.123. This is 23.3. And the final reading is 48.12345 6. This is 48.6. And in the third titration, the initial reading is 7.123. So this will be 7.3. And the final reading 32.1234, 32.4. It is important that before you make these recordings, you must look at the scale and try and understand the scale. This is 0.9. Do not forget that. Okay, we go to the table of results. The initial reading here is 0 cubic centimeters. The BGCSE syllabus recommends that you write this to 1 decimal place as 0.0, not just a 0. The final reading is 25.9. So this will be 25.9 cubic centimeters. You go to titration 2, 23.3 and 48.6, 23.3 and 48.6. You go to titration number 3. This will be 7.3. So that's 7.3, and the final reading is 32.4. This will be 32.4. Calculate the volume used. The volume used is equals to the final volume minus the initial volume for each titration. So subtract the initial reading from the final reading to get the volume used. And in the first titration, our volume used is 25.9 cubic centimeters. There is no need to write the units in the table because the units are already given in the columns here. Okay, so this will be 3, this will be 5, and this will be 2, and this will be 1, and this will be 25.1. That is how you record your results. And then the last row says you should take the best titration results. The best titration results are those that are close to one another. When you look at your results, you will note that the difference between these two readings is 0.2. The difference between these two readings is 0.6. The difference between the first titration and the third titration is 0.8. So the only results that are close to one another are these ones of titration number 2 and titration number 3. So we'll take that as our best results. there is no need to put an X here as a way of trying to indicate that you do not tick it. Do not place an X. Just leave it as blank. That is sufficient like that. So these are our best titration results. The next question says, use these results, not just all the results, but your best titration results to find the average volume of the hydrochloric acid used. The formula says the average is equals to the sum of volume used for the best titrations divided by the number of best titrations. The sum of the volume for the best titrations, our best titration here, okay, let me write average volume is equals to the sum of the best titrations. The volumes on the best titrations, we've got 25.3, add that to 25.1 to get the sum of the volumes in the best titration, divide by the number of best titrations. The number of the best titrations is 2. When you press your calculator, you should get 25.2 cubic centimeters as your average volume.